Cold joints occur whether in new construction or bridge expansion projects when new concrete is placed next to older concrete. AASHTO Bridge Design Specifications recommend the strut and tie method for the design of these areas, but more specific guidance was needed.
We have cold joints on a lot of different situations. Sometimes it's current construction where you cast concrete but you don't have enough time to do the whole thing, so you have to do part of it the next day. Sometimes we widen structures, so the existing concrete could be decades older than the new concrete.
The Texas Department of Transportation and researchers with the Center for Transportation Research examined the issue and developed recommendations for the design of cold joints in Texas bridges.
Our bridge design specifications published by AASHTO did not make explicit recommendations on how to construct what we call strut and tie models in cases where we have load transfer taking place between two different types of concrete, two different ages of concrete, and so on.
At the beginning, there was a literature review, so they looked at to see what was out there already. Then they went and they did a survey. So we reached out to different DOTs to see how they address cold joints. And then we went to the experimental lab testing.
The research took place here at the Ferguson Structural Engineering Research Laboratory, and load transfer mechanisms at different scales, ranging from material scale tests to component scale tests, took place. We have studied boundaries and connections that are vertically oriented as well as horizontally oriented, and some inclined boundaries to be able to understand and explain the structural behavior that we were seeing. And as is common in our research projects, we have looked into the problem by running some sophisticated analyses as well to where we can actually understand the load transfer mechanisms.
TxDOT got a design example step by step. There's also a flow chart. So you can use different factors depending on if it's a vertical or a horizontal, or if you roughen the surface, if you put reinforcing across the surface. So it's giving the engineer more information and more knowledge to use.
This is a good project that is ripe for implementation because the findings here can be implemented into real-world applications and studies. And we came out with recommendations that we will propose for TxDOT's use as well as the national use on how that load transfer takes place, what are the important considerations, and what to check and how to move forward.
For more information and to find the publications for this project, please visit the TxDOT Research Library at the link shown below.